Hello everyone. We're going to be doing this question where there's a person inside an elevator and he's pulling himself up with a rope. All right. So the person weighs 70 kilos and the elevator weighs 30 kilos. Now, the first thing I'm going to do right now is label these M1 and M2. M1 is the elevator and M2 is the person. This is going to help simplify the equations that we make. Okay, so I'm just going to write here M1 equals 30 kilograms. M2 equals 70 kilograms. Anything else? And gravity equals 10. Okay. And you see them here. Gravity equals 10. Alright. So, as you see in A and B, we have to draw the free body diagrams of both the person and the elevator independently. So, I'm going to draw the elevator first, since it's M1. Okay, we can draw it like that. So, first, we have a force of tension. Force from the tension that is pulling it up. Because the person pulls it down, it pulls the elevator up. We also have the weight of the elevator, which we will write as M1 times G. And we also have the normal force of the person that's pushing it down, which we'll just write N, because we're going to be comparing normal forces and it's equal on both. So the elevator gives the same amount of force up to the person as the person exerts down on the elevator. So we'll just label it N. And so that is the free body diagram of the elevator. That's all the forces acting on it. And so we can write the sum of forces on the elevator on body 1 as tension minus N and minus M1 times G. Right, that makes sense because they're in different directions. All right, so we also want to compare it since later on we are going to use right here acceleration. We want to compare this to F equals ma. So force equals mass times acceleration, and this is the sum of forces on the elevator. So whatever force is acting on it has to be equal to the mass of the elevator times its acceleration. Okay? All right then. So now we move on to the free body diagram for the person. Again, the person is pulling down on the rope. So the person is exerting a force downwards on the rope, and per Newton's third law, the rope exerts a force equal in magnitude opposite in direction onto the person. So actually, the rope is pushing the person up, or like pulling the person up, basically same magnitude and direction as tension. Okay? We also have the normal force of the elevator exerts onto the person, which is N. And we also have the weight of the person, which is M2 times G. Okay. So here, the sum of forces on the person is tension plus the normal force and then minus M2 times G. And this is also equal to M2 times acceleration. All right. That's going to mess with some people's OCD. Okay. So now that we found the sum of forces on both people, we want to figure out how to combine these equations to give us an answer where we can find the normal force. Because look, the question is asking us to find the reaction force on the person from the elevator floor. Now, sometimes when you do this question, and you will see questions where it asks you to do this, you're supposed to combine these two free body diagrams together to make a free body diagram for both, like that includes both the person and the elevator. And how you do this is you'll add both equations, right? But there's a reason why this question does not ask you to draw a free diagram for both. It's asking us to only draw for the elevator and the person. And that's because we want to minus one of these equations from the other so that we eliminate tension and we only have the normal force inside, because T minus T would be 0 and N minus N would be minus 2N, or the other way around. All right. So we'll label this as equation 1 for body 1, and we'll label this equation as equation 2 for body 2. Okay. So since this is already positive N and this is negative N, I'm going to take equation 2 minus equation 1. And I'm gonna lay this out in a way that I won't make mistakes because I'm quite prone to making them. So I'll lay them out like this. I write the second equation out up here, and then I write the first equation here, and I put a minus sign to symbolize that I'm taking it away from the first thing. Okay. Let me just check if I wrote them right. Okay. So this will result in t minus t is 0t. N minus n is 2n. And I'm going to write it down here. 2n. And then I know you can factorize this straight away, and if you can, you should, but I can't. So what I'm going to do is just write these out and then factorize them later, because when I try to do things too fast, I make mistakes. Okay. So now we simplify. We simplify by factorizing these. So, my bad. I made a mistake there too. So when you minus, that would be plus. So plus is here. And so this would be, I'll put the m in front. Like that. And like this. Here we go. And now since we're trying to find the normal force, we want to isolate the n. So we'll rearrange the equation so that n is on the left side. And that should be like this. All right. So now we just substitute the numbers in. And so when the elevator is accelerating upwards at 0.5 meters per second, and notice how every time we had a vector that is going up, we label as positive, and a vector going down as negative. If you've done it the other way around, like for example, t here is positive because it's going up, and n here is negative because it's going down. If you've done it the other way around, this won't work, right? You'll have to reverse the polarity on your things. It's a whole bit of mess. So you want to keep on top of your directions. Okay. So here we substitute 0.5. M2 is 70 because that's the person, minus 30, minus 10 because gravity is 10 for this equation, times the elevator is 30, and then minus 70. And this all over 2. That leaves us with, I just type this into my equation calculator real quick. 30 minus 70 over 2. That leaves us with 210 newtons. So the normal force that is acting on the person from the elevator when the elevator is accelerating by 0.5 meters per second squared is 210 newtons. All right, moving on to question D. The force on the person exerts on the elevator is 300 newtons. Find the acceleration of the elevator. All right. So we just want to, so rather than having n on the left side, we want to have a on the left side. So we're going to do it over here. I'm going to write a, and we're going to use the same equation over here, just rearrange it a little bit. So a would be equal to 2n plus g times n minus 1, m1 over m2 minus m1. All right. So here, the normal force is 300. So that would be 600 plus 10 times 30 minus 70 over 70 minus 30, which is 40. All right. So the elevator is accelerating 5 meters per second squared. All right. So that's the that's how you do it. Make sure I'm so sorry. I forgot to label the questions. So this is question D. this is question C, and A and B is up here. Okay. All right. So you can take a picture of this, put it in your notes, whatever. Anyways, thank you guys for watching.